one other big concept that we talked about was energy. And there are three types of energy. There's kinetic energy, there's internal energy, and there's potential energy. And so kinetic energy, we wrote kinetic energy equals 1/2 the mass times the velocity squared. So this is just for linear motion. But then we also had a kinetic energy for rotation, which was 1/2 I omega squared. And so that's actually related to work and related to forces in the following way, that the change in the kinetic energy of any object is equal to the net work, which is just the integral of the net force with the dot product into the position, basically how much it's moved. So this, this can become the displacement. So if we have a constant net force, this can be, F net dotted into the delta R, which is the displacement. And then we have internal energy, and this basically comes from non-conservative forces. So non-conservative forces are things like pushing and pulling, and so there's chemical energy, thermal energy, nuclear energy. And then we have conservative forces, which have a potential energy. So this is the third kind of energy. And we only saw two kinds of conservative forces. So we saw gravity and elastic, basically a spring. And so our gravity potential energy is just the mass times gravity times the height above some reference, right? So this is like some reference height, which you can define. And then we have our elastic potential energy, which has this equilibrium in it. So that basically means that if you have a spring and it's at rest, at some place, so then our place where it's at rest is x equilibrium, and so basically we have 1/2 k, and then this is like a delta x squared, where the delta x, right? So this is our delta x. Is given by how much it's basically been stretched, if our mass is now over here. And so we can relate the work done by either of these conservative forces, the gravity force or the spring force, and just say it's equal to minus the change in the potential energy for that related force.